so welcome. And you know, some of you may be familiar with Biohabitats work. We work on a wide spectrum of water infrastructure, everything from a very naturalized water infrastructure, so like our rivers and streams and wetlands and coastlines. And on the other end of our water infrastructure spectrum is our built water infrastructure. So our stormwater, wastewater, rain harvesting, and water reuse systems. And that's some of what I'll be focusing a little bit on, is some of that built water infrastructure. And I always like to kind of point out my specific biases in this work. And I'm a firm believer that water is a part of our commons, and is really access to water is a human right. And that sometimes is at odds with being a water resource engineer in the built environment, when we're trying to understand the value of water and make sure that it's the cost of producing clean water and distributing clean water is equitable, but also the decisions we're making around the infrastructure are smart financial decisions. And a diagram that I've shared in many of my talks. This is from 2015, put out by Circle of Blue, of kind of the cost of water around the U.S., broken out in different segments. Portions of the pies are either wastewater, potable water, or stormwater delivered. And this is a little outdated, but still reigns true in the diversity of the cost of water around the country. I do want to plug Circle of Blue because I think they're continuing to do some exciting research, and they do have a series that just came out, an audio series and an article that came out updating some of the figures through 2019. And one of the things that was interesting in that data, and they've been tracking the 30 cities in the U.S. Water cost and the value of water, and they've been looking at the increase of water costs over that time period. And so over the last 8 or 9 years, the percentage increase in water has gone down quite a bit, from close to 9% increase in 2010 down to more like 3% increase in the last few years. And so, and I think to add to that is where utilities are starting to increase water is in a rate structure that might be changing the base rate of what someone is charged versus a consumption rate, which is kind of how much you use. And that affects how how as a water resource engineer, we may want to look at, water saving devices, water efficiency, and reducing water rates is one way to kind of pay for those improvements. But when your base rate goes up and not your consumption rate, saving water is kind of less financially meaningful. So what that means is we need to find other ways to value water infrastructure outside of the kind of pure economics of purchasing water. As we know, water is fairly cheap, and it's pennies per gallon for most of our utilities. And when we're working in the built arena, as I mentioned, the end of spectrum that Biohabitats works a lot in, we're often working on high performance buildings, LEED Platinum or Living Building Challenge projects that look at a variety of building water cycle systems, and it can be a little overwhelming and complicated as we're trying to make decisions about water infrastructure, whether we're capturing rain for use or we're treating gray water or black water to reuse in a building. And maybe simplify it a little bit. We're looking at discrete chunks of infrastructure within a building or a district setting to treat and use water appropriately. And just to share kind of a couple examples of how that infrastructure takes shape and isn't just used to, as we talked about, treating water, but is used in other valuable ways in our built environment. The Candida building, which some of you may be familiar with at Georgia Tech, has a variety of water infrastructure systems, including rain harvesting, composting toilets to deal with human waste, and some gray water systems. But the way that infrastructure is integrated into the building and into the built environment isn't just to treat water. It's a whole placemaking and educational system. There's the mural on the wall that shows part of the water cycle and explains what's happening in the infrastructure. It's part of the placemaking. And so that's what we're looking at when we're thinking about what the value of water infrastructure is not just treating water, but it's what are the other benefits. Just to share a couple other examples, Sidwell Friends School is it's the first LEED Platinum school, just celebrated, I think it's 15th or 16th year. The entire landscape of this building is water infrastructure, both their stormwater, their wastewater, and rain harvesting system. And all of that doubles as kind of educational components of the school. And it's beautiful and educational. We've wrapped interpretive signage around components, and students use that to give tour of their school. They're tracking water recycling on their building's dashboard. And so again, that's part of the curriculum, both for math and science and social studies. And as I mentioned, it is a beautiful place. And you don't necessarily know when you're walking over the water infrastructure to enter the building that's what you're doing. On the right, you see that's a picture of the constructed wetland that's treating 100% of the waste that's coming from the building. The pond in the middle is part of their science classroom that also is a stormwater recirculation pond. And we recirculate that water through this flow form on the left side, and that provides a little ambient noise as you come in and cleans the water as it introduces oxygen as it goes through that flow form. So it's not just treating water. This infrastructure is adding all sorts of value to this project, and definitely turns its kind of typical schoolyard idea on its head, and how we're integrating these systems. And sometimes these systems blend together and you're not exactly sure where one starts and stops. And sometimes they're defined in a way that is a little more specific and discrete. Here's a picture of that kind of access down to the stormwater pond. And so we're looking and always trying to understand how we take water infrastructure and add value to it, whether it's beauty or educational, or something that really kind of frames a place. This is a system of ours in Portland, Oregon, that treats wastewater from 650 apartment units. And this is the front door of this residential community. And you're looking at its wastewater system kind of on its front doorstep. There are trickling filters in the background and constructed wetlands in the foreground. And a grocery store is right off to our right. And so they have cafe tables so you can sit out, enjoy the placemaking of this project. Great design by GB Architects, and Place Studios as a landscape architect, and a whole host of other consultants. Turner Engineer was the contractor on this, and it really took an amazing integrated team to pull something off like this. And the placemaking doesn't just stop at the kind of physical structure, it's also the how it's communicated. So this system has a Twitter account that tweets about sustainable programs that are around the development. And so the value of how this water infrastructure is integrated is there. But how do we assign that value is maybe something that we can discuss today. There are all sorts of stacked benefits that we can look at with highly integrated infrastructure, not just wastewater treatment, but the system is part of the pedestrian circulation. It allows for emergency access. It's landscape, it's branding, it's water reuse, it's educational, increases biodiversity, all of these things of value. But when we're looking at making decisions on our water infrastructure, we're typically again focused on, what's the return on investment from water savings? So how do we integrate some of these other benefits into it? And I didn't want to just gloss over the challenges that we have with some of this work. With stacked benefits comes stacked challenges, and so these are opportunities for smart integration and coordination. But there's a lot of work that needs to get done when you are doing this integrated work. And we can talk about maybe some of those challenges that folks are seeing. And if you have challenges you'd like to discuss, again, use the chat window to put those out there, and we'll try to call those and lead a discussion here in a second. And maybe I just one or two more slides to share. This isn't just in the built environment. I think this integration and using water infrastructure for multiple benefit can happen at many scales. This is a constructed wetland just west of Portland that treats between 5 and 18 million gallons of wastewater a day. But it is a community asset, has trails around it that allow for bird watching and a tranquil walk. Also has 2 outdoor classrooms and is used by school groups and is just a beautiful place. When I was one of the last times I was out there was an artist painting the
I just sent you a go-to meeting. You might want to jump on.
Is an artist that's painting their wastewater treatment plant, something you don't often find. So with that, just kind of introducing different ways we can look at water infrastructure and how we might find value in other ways. We can open up discussion, and shameless plug to share a picture of my kids. With that, I'm gonna lean over to my other window here and see if Aaron has been tracking any of the comments. Let's see.
Yeah, none yet, Pete. So I think the field is wide open.
Okay, great. Thanks, Kathleen. Yeah, those are my girls, August and Hazel, and they're 3rd and 5th grade, and they're loving to experiment with virtual learning right now. It's pretty neat. So I'm curious for when folks are having conversations, either if you're part of a design team or if you're a client, what are some of the discussions you're having about integrated water infrastructure? And is it purely focused on return on investment from water, or are there other things in the conversation?
And Pete, there is a question from Rory Gilchrist that ties in to what you were just asking, which is whether or not the placemaking benefit is enough to convince a skeptical client about decentralized water infrastructure, and how much do they, with what frequency are they changing their mind?
Yeah, that's a great question. I think it depends a lot on the client. There's a great video that some kids at the Sidwell Friends School produced about the atmosphere of the school that is created and what the building and the landscape did for their educational for their time at Sidwell. It's a really compelling. It's about a 4-minute video. It's on their website. It should be fairly easy to find, or I think if you YouTube Sidwell Friends, and you can just hear in their voices the like how meaningful kind of growing up in a place that at every turn they were learning something, and the beauty in which that was placed. And after hearing something like that, it's hard to argue the value of what that environment produced for that school. So where we see kind of an easier, where we notice an easier time with talking to clients about this are places of learning. So whether it's K through 12 or higher education or nature centers or other kind of learning centers, children's museums, those type of things are often that's an easier play. But we're starting to see traction in other project topologies, whether that's housing, affordable or mixed rate, whether that's commercial office. I would say some of the larger office complexes that are more district and campus projects. They're looking at integrated landscape and the value of that placemaking is key. So great, that's a great question.
There's a few more pieces that have come in.
Yeah, go ahead.
I don't know if you're able to see those, but Ethan Applegren was asking if you could talk a little bit about how to integrate wastewater wetland systems, and specifically how was that received by the public in some of these areas that are pretty open.
Yeah, so as you notice, some of those pictures, the wetlands are highly, and I'll just back up an image or two. I think I can do that without too much trouble. We're looking at something like Haslow on 8th. There's the wastewater system is all of that vegetation there on the bottom left, and there isn't a giant fence around the wastewater plant, right? And so it's highly accessible from a placemaking perspective. As engineers, one of the first things, or one of the most important principles, is health and safety of the community, and so we're often communicating early on with a client and stakeholders about how we're managing health and safety. So the water in the treatment system is always below surface. We're scrubbing any potential odors that come from the system. We're making sure we're limiting access to critical components. And so that's very much a conversation that happens a lot in early stages of our concept and design development.
There's two questions, Pete, that are somewhat interrelated about municipal scale systems from both Muñoz and Kathleen Smith. And so the first question was, does this apply and can this be applied at a municipal scale? For example, if your riverside town has an antiquated combined sewer and stormwater system, which I can comment here is that Fernhill project that Pete showed is a municipal scale project that was trying to solve a riverside town's problem with temperature. So that is possible. But also Kathleen's take on this was that she gets the question, and she's with the International Living Future Institute, about, there's basic costs of, return on investment and infrastructure costs, but there's a bigger question people often ask her, which is, why would you do these decentralized systems, even if you understand the stacked benefits, but why would you do those if you did have access to a municipal system? Or in some cases, is it better quality or more reliable at the municipal scale. And so how would you speak to those questions?
Yeah, a bunch of different questions in there. Let me see if I can unpack some of them. In terms of quality at the municipal scale, kind of work backwards, and Aaron, you can please help me remember the questions as I go through them. But municipal scale, that's a little bit of a misnomer that it's better at municipal scale in terms of recycled water. The opposite is true in a lot of our West Coast communities. For a long time, folks in the Bay Area did not want to use reuse water because of the amount of salt that was in the collection and distribution system for that water, and so that it was fairly salty, and so people didn't want to tie into the municipal system, but were excited about a smaller decentralized system, maybe at the building or neighborhood scale. I think they are, I don't want to badmouth the Bay Area. They've been tackling that problem and working on closing up some of the saltwater intrusion in their collection system, and I think that's valuable time served. But I would say the additional value in a smaller district scale is the resilience that it gives, and not being reliant on municipal rate fluctuations or the availability of water, or in times of disaster, catastrophe. The municipal system may be offline, but if you have a building scale system, you might still be able to operate. So the added resilience is certainly something that we've seen of interest, especially in the Cascadia region as people plan for the Cascadia quake, and certainly some of the planning for the big one in California as well. Aaron, what was another part of that question? I think maybe the first part.
The first part was, is it, has anyone looked into employing these kinds of systems on a municipal scale, particularly in this case for a small riverside town that has an antiquated combined sewer and stormwater system?
Yeah, certainly what we know about early high performance buildings, and we were early adopters of kind of the LEED green building framework, and we're involved in a lot of the early LEED Platinum buildings. What we know is water infrastructure rarely optimizes at the building scale, right? And so while it doesn't optimize at that scale, it still could be extremely valuable. And so it's valuable in a way of changing the people's attitude around water infrastructure and water in general, which I think is a huge asset, and where some of those early adopters are making a kind of a statement and a place in our work. But I don't think our goal would be for every single building to have a standalone wastewater treatment system that was, reusing it. Where we tend to see a lot more traction and a lot of interest is at the neighborhood and district scale. This is through some of the work with eco districts and the Living Community Challenge. The difficulty in that is that our regulatory framework is not always aligned with some district scale solutions. So there's been trying to understand some of the complications there. And certainly, water infrastructure, there's an economy of scale. And so the more you can tend to pull things together, the cheaper per gallon it gets. There's a limit to that, where you look at infrastructure like the wastewater system for Detroit, Michigan, and I can kind of badmouth them because I'm from there. So I have a license, but that system is so massive and so huge and takes almost a quarter of the state's population, takes their wastewater, and they spend a ton of energy getting all this wastewater to a single point, and that's a costly endeavor. And the issue with now, if they were ever at a single point, if they wanted to treat it to a reuse quality and send it back to everyone, it was taking an enormous amount of energy and infrastructure to do that. So the closer you can be to where water is generated and where you can treat that and reuse it, the better, and certainly changes the economy of scale.
Great, Pete. This is Erin. I'm just going to chime in very briefly as the co-host here for Pete for this week, anyway. Yeah, and that also, I think part of that first question was, you know, do natural treatment systems scale at the municipal system scale? And I think the answer to that is absolutely yes. And it also depends a little bit on, you know, land availability, but many of these systems, which we've adapted for a very urban setting in the examples Pete showed today, can absolutely kind of expand out to be used at scale. And if the land is available, these technologies have low energy and carbon footprints. They have low electricity requirements, and can produce, you know, pretty high quality water, particularly when combined with, you know, some additional filtration and disinfection. So absolutely yes. And there are many examples actually of either retrofitting or fresh builds with natural systems at the municipal scale.